Okay guys, so what I'm going to do is I'm going to show you the translation video that we saw in class, and specifically what I'm going to do is explain it as we go, just like what I did in class without the volume of the video. But I really like this video because what it does is it shows you the whole process instead of just showing you pictures and explaining. So this is your mRNA, alright, so that's been copied from the DNA in the nucleus during transcription, and now the process we're looking at is translation. So in comes, right here, your ribosome, okay? And what it's going to do is it's going to look for a codon, okay, 3 letters that tell it to start, okay? And that where it starts is called the initiation site, but that's not important to us. It's going to look for something to tell it to start, okay? And then in is going to come the first tRNA. Now tRNA is a type of RNA, all right? Here's your amino acid. And here's what we call your anticodon. Now your anticodon is what is going to match up with a complementary part on the mRNA. So UAC would match up with A, T, and G. Or sorry, not T, because it's RNA. A, U, and G on the mRNA. Okay? So AUG right there, it's going to match up with it. Okay? And so the important thing, guys, is that on one side of the tRNA, you've got an amino acid. On the other side, you've got your anticodon. All right, so that's what the tRNA does. Based on the codon that you find in the mRNA, it's going to bring a very specific amino acid in. All right, so there's your amino acid. There's that red dot right there. That's a type of amino acid. Right? And then in's going to come the large subunit, because ribosomes are made up of 2 subunits, the small and the large subunits. Okay? And now starts our process of translation. Okay? They're just showing you side view, side view. Oh, so in comes the second tRNA. So it's going to go to the codon that it's complementary to. So as you can see, okay. And I don't care about the sites, guys. This is just the first and second site. That's fine. What you need to see is that the next tRNA comes up, lined up with the mRNA. Okay? And watch what happens to the amino acid. It goes from here, it's attached to the tRNA, then it's going to be released. Okay? It's about to happen. Oh, released, and it's going to join with the orange amino acid. Okay? What holds these two together is a specific type of bond, and we call that a peptide bond. Now, the tRNA, once it's released its amino acid, is going to be released, and it goes off. Okay? New tRNA comes in. Okay? This little chain of amino acids is then going to be linked to the yellow one, so you can see it happening. Now, this tRNA is going to go off. New one in, chain moves over, that tRNA moves off. And so you're creating what we call a polypeptide chain, a long chain of amino acids. Okay, and notice the mRNA is also moving. It's kind of like a factory, keeping going. And this process of having a longer and longer and longer polypeptide chain is called elongation. Now, the important thing is this right now is not a protein. It's called a polypeptide chain. In order for it to be considered a protein, it has to twist, turn a little bit into a 3-dimensional shape. Then that's when we consider it to be a protein. So this whole process, guys, with the ribosomes is happening in the cytoplasm. It's not happening in the nucleus. So the mRNA that was edited goes from the nucleus into the cytoplasm, then it's used by the ribosomes in the cytoplasm to make a polypeptide chain. That polypeptide chain then twists about a little bit, and that's how we get a protein. Okay, so it's a pretty cool process. And that's it, guys.